project is sponsored by PCBWay. From concept to production, PCBWay provides cutting-edge electronic design solutions for global innovators including hardware design, software development, mechanical design, product testing, and certification. PCBWay engineering team consists of experienced engineers in electronics, embedded systems, and product development. They successfully delivered hundreds of projects across industries such as medical devices, industrial automation, consumer electronics, smart home, and IoT. Hello! Some time ago I presented you a project for a 3-watt stereo tube amplifier with GU32 output vacuum tube. This time I will present you a way to make a quality stereo tube preamplifier with 3 selectable inputs with ECC83 vacuum tubes. The circuit diagram is taken from a local electronics magazine emitter, and the author of the project is Mr. Emilian Iliovski. You can freely make the device for your own needs, but in case of commercialization you should first contact the author. From this project I will use only the preamplifier part with minor modifications, and I will implement the power supply in a slightly different way. The heart of the preamplifier are 2 well-known ECC83 tubes, vacuum tubes that are widely used in quality branded audio preamplifier stages. The original project contains a number of characteristic elements that are relatively difficult to obtain, but I tried to replace them with standard available components without major losses in quality. At the end of the text, the original circuit diagram for one channel is given and the other channel is identical. In almost all tube projects, the most difficult part to purchase and make is the power supply stage. This project in particular uses a 250 DC power supply plus 12 volts for heating the cathodes of the tubes. I solved this in a very easy and elegant way with the help of this cheap DC-DC boost converter. This preamplifier does not require high currents, so this converter is ideal for this purpose. The input voltage for the converter is 12 volts, and the same voltage is used for heating the tubes. At the output of the converter, I set a voltage of exactly 250 volts using this small multi-turn potentiometer. Now let's look inside the preamplifier. In one part there is a DC-DC module which is desirable to be shielded to avoid interference with the preamplifier. Also the preamplifier PCB as well as the input section should be shielded for the previous mentioned reasons. I currently have them unshielded for better visibility during the presentation. The coaxial cables used should be as high quality and short as possible. For the same reason, the voltage dividers for the attenuation are made directly on the input connectors themselves. I use 2-on-6 switch to select the inputs. The original project contains an attenuator instead of a potentiometer, but for a sake of economy and simplicity, I decided to use a standard potentiometer. In fact, the original project is titled High-End Audio Preamplifier, which is confirmed by the measurements performed, but I did not have such strict criteria for this particular project, and my goal was a proof of work but also a relatively good mid-high class preamplifier. Here I measured technical characteristics and the subjective description of the sound quality from the author's side. Frequency range 20 Hz to 100 kHz on plus minus 3 decibels and 42 Hz to 20 kHz at plus minus 1 decibel. Distortion, second harmonic 0.8% and third harmonic 0.1%. Fourth harmonic 0.3%. Signal noise ratio 81 decibels. And channel crosstalk 78 decibels and 1 kHz. Sound characteristics fills the room with a pleasant and soft sound, very good reproduction of the mid-range with excellent separation of wind instruments. A small dose of undefined sound image in string instruments. Pleasantly surprising is the excellent dynamics of mid-range and high tones. At the time of production, I did not have enough quality MKP capacitors, but I will certainly purchase and install them in place of the standard ones in the future. Also, the tubes I used in these projects were taken from old faulty audio devices, but I plan to replace them with new quality ones. Now let's see how the device works in real conditions. First of all, let me tell you that this is one of the rare projects that worked for me right from the first test. In fact, in these tube projects, there is almost no way to do any major damage as a result of incorrect connection, which is a common case with semiconductor devices. Of course, the video will in no way be able to capture the real sound, so you will have to trust my claims or make it yourselves and hear the sound quality. In this presentation, I use an output amplifier with GU32 tube, shown in one on my previous projects. The source of the audio signal is my PC. I must say that I'm very pleasantly surprised by the difference in sound when I feed the signal from the PC directly to the power amplifier and through this preamplifier. This is probably due to the adjusted impedances between the preamplifier and output amplifier. Although I am not using quality audio grade capacitors for now, the sound is, in a word, wonderful, and it is really worth your while to make this preamplifier as part of your audio system. Here is really expressed that soft, pleasant sound characteristics of vacuum tube audio devices. I even tested it as a preamplifier stage of a model integrated amplifier, and I can conclude that it greatly colors the sound, bringing it closer to the tube sound. In fact, it is pointless to get into debates about sound quality, primarily because it is a subjective category, and not to mention that nowadays the younger generations compete in the quality and volume of sound on their mobile devices and phones. Even in this video, but only for practical reasons, I use compressed MP3 music as the sound source. It is really funny but also sad. For now, I have omitted several components here, such as timer for preheating tubes, shielding of all modules, and attenuator instead of a potentiometer, and other little things that should certainly be included in the final product. And finally, a short conclusion. In the original project, this preamplifier is defined as a high-end audio component, so if you strictly adhere to the recommendations and the schematic diagram given by the author, it will be worth much more than the invested effort and money. I say this based on the listening tests, specifically of my preamplifier made with standard relatively cheap components, and also from the experience of several of my previous successfully completed projects from the same author.